Today we are going to learn a little bit more about trapezium. Now, in last class, we had learned basic properties of trapezium and how to find the area. Now, if we move forward from there, what we can say that if a trapezium ABCD is such that AB is parallel to CD, and if we join BD and CD, AC, the diagonals. So what can we say? That as line AB is parallel to DC, if angle B will be equal to angle D, angle ABAC will be equal to angle ACD. So one very important concept that we get here is triangle A, the intersection point is O, so AOB will be similar to triangle COD. Or we can say that the side ratio, which is AB upon CD, AB upon CD will be equal to OA upon OC, which will be equal to OB upon OD. Okay. So let's say if this side length is A, this side length is B, so this will be equal to A by B. And in that case, we can also say that the ratio of area of this triangle, area of triangle AOB divided by area of triangle COD will be equal to square of the ratio of corresponding side lengths. So it will be A by B whole square. Okay. Now think about this. If I say that area of this triangle is A square X, X is some constant, then area of triangle COD will be B square X. The ratio is A square upon B square. In that case, think about this. The ratio of the side length OB is to OD is A is to B. So the area of the corresponding triangles, which is triangle AOP and triangle AOD, will also be in the ratio of A is to B. So in that case, the area of triangle AOD will be ABX. And similarly, area of triangle BOC will also be ABX. So in any trapezium, these two triangles will be of equal area. Apart from this, we can also say that product of these two triangles, which is AOD and BOC, will be equal to product of the remaining two triangles, which is AOB and COD. A square B square X square, A square B square X square. Okay, so I hope this part is clear regarding trapezium. Now, let's try a few questions based on this. First question says a trapezium ABCD with sides AB parallel to CD has diagonals intersecting at O. So first let's draw a trapezium ABCD where AB is parallel to CD. So A, B, C and D. The diagonals intersect at O. So this is O. Now it says area of the trapezium is 256 square units. 256 square units. Length of AB is 6. This is 6. Length of DC is 10. Find the area of the triangle AOD. AOD. Now what do we know? We know that if this area is X, this will also be X. Right? Right? Now we know that AB is to DC is 3:5. If AB is to DC is 3:5, OB is to OD will also be 3:5. So instead of taking X, if I take this as 5X, this will also be 5X. And in that case, this will be 3X. Right? Now, can we say that what will be the area of this triangle DOC? So product of these two should also be product of these two. So product of these two is 25x square. So this will be 25 upon 3x square. Right? Now, in that case, if I add all the areas, can we say it will be 5x plus 3x plus 5x plus 25 by 3x. this is not x square, this will only be x. This is equal to 256, or if I take 3, so this will be 15 10 plus 3 13, 39 and 24, 64x upon 3 is equal to 256. 64 into 4 is 256, or x is equal to 12. If x is 12, we need to find area of triangle AOD, which is 5x. Area of triangle AOD, which is equal to 5x. If I put the value of x, it will be 60 centimeter square. All right. So our answer is option D. Now, next question says, what is the length of the line segment that divides a non-isosceles trapezium with parallel sides 3 centimeter and 21 centimeter into equal area trapezium? So again, let's say this is A, B, C and D. So what is the length of the line segment that divides a non-isosceles trapezium with parallel sides 3 and 21 into 2 equal area? Now in this case, a little bit of part is missing, that line parallel to with parallel sides. Okay, length of the line segment. So let's say the line segment is this, which is EF. So we know that parallel sides A and B, AB and CD are parallel. EF is also parallel to AB and CD. Okay, as I said, this part is missing. What is the length of the line segment parallel to parallel sides? Okay, that divides into 2 equal area, means if this area is x, this is also x, and side length is given, which is this is 3 and this is 21. So how do you find the length of EF, right? This is what we need to find, length of EF. Now what we can do to solve this question is extend this line and join this somewhere here. Now can we say that if this point is M, area of triangle AMB, let's say area of triangle AMB is P, can we say that the ratio of the parallel sides, means AB upon CD, is equal to 3 upon 21, which is equal to 1 by 7. So area of triangle AMB is P, then area of triangle whole DMC will be 7 square into P, which is 49. P, area of triangle ADC divided by area of triangle AMB will be square of the corresponding side ratio, which is 49 upon 1. So can we say the area of this whole triangle ABDC will be 49P. This is P. Area of this quadrilateral and this quadrilateral is equal. Can we say that overall area of this quadrilateral ABCD will be 48P. So x will be 24P. This will also be 24P. That means we can say that area of triangle AEF divided by area of triangle AMP will be equal to, this is 24 plus 1, 25P divided by P, which is 25 upon 1. So the ratio of corresponding side lengths, which is EF divided by AB, will be square root of this, which is 5 by 1. So if AB is 3, can we say EF will be equal to 15? And so our answer is option B. All right, this is 3, this is 21. So we need to find the area of the length of EF, and that will be equal to 15 centimeter. Next, in the given figure, ABCD is a trapezium. Line FE is parallel to AB and DC. So AB is parallel to FE, which is parallel to CD. AB is equal to 4 centimeter, DC is equal to 12 centimeter. Find the length of the line DE. Now can we say that in triangle DAB, AB is parallel, let's say this point is O, AB is parallel to FO. What is the side ratio? So AB is to DC is 1:3, right? AB is to DC is 1:3. So OB is to OD will also be 1:3. Similarly, AF is to FD will also be 1:3. So if this is X, this is 3X. Similarly, in triangle DBC, can we say OB is to OD is 1:3, B is to EC will also be 1:3. So if this is Y, this will be 3Y. So their bases will also be in the same ratio. So OF, what we can say, OF upon AB will be equal to 3x upon 4x, which is 3/4, or we can say OF will be equal to 3/4 into AB, which is 4. That will give us 3 centimeter. Similarly, can we say OE upon CD? OE upon CD will be equal to, this is Y, this whole is 4Y, so it will be 1/4, or we can say OE will be equal to 1/4 into 12, which is again 3 centimeter. So what do we want? We want FE. FE will be equal to OF plus OE, which is equal to 3 plus 3, that is equal to 6 centimeter. Now remember, if ever you get this, that length of AB is A, length of DC is B, and EF is parallel to AB and DC such that it's going through the intersection of diagonals, then you can simply find FE will be equal to B upon A plus B into AB plus A upon A plus B into CD. This you can directly apply if length of these two sides are given. A and B are their ratio or actual value, doesn't matter. So B upon A plus B, see, B is 3 here, this is 3, and this is 3 plus 1, 4. This is 1, 1 plus 3, 4, and into CD. You can directly use this and find the length of EF. Now next question says, if D and E are the midpoints of the non-parallel sides of the trapezium, then find the length of the D if parallel sides are 8 centimeter and 12 centimeter. So again, we need to draw a trapezium, right? So trapezium is A, B, C, D, and D and E are midpoints, right? D and E are midpoints. So let's take this PQRS. P, Q, R, and S. So midpoint of this, like this. Then find the length of D if parallel sides are 8. This is 8 and this is 12 centimeter. Now think about this. If I join this line, can I say this is midpoint and this line is also midpoint? This point E is also midpoint. So this will also be midpoint of QS. And so D will be parallel to SR. So these two lines will be parallel to each other. Now think about this. This is 8. The ratio is 1:1. If this is 8, this will be just half of it. So OD will be 4. Similarly, OE will be half of SR using the midpoint theorem. If this is 12, this will be 6. So we can say DE will be equal to 4 plus 6, which is equal to 10 centimeter. Or you can directly remember this, that if D is midpoint of PS, E is the midpoint of QR, then DE will be equal to half of sum of parallel sides, which is PQ plus SR. So this is 12, this is 8, sum is 20, half of 20 is 10. So our answer is option B, right? Next question. ABCD is a square. Area of triangle AQB and triangle CQE. AQB, CQE are 16 units and 9 units respectively. Find the area of the square ABCD. So ratio of area of these two triangles is nothing but 16 is to 9. These AB is parallel to EC. That makes these two triangles similar to each other, because this angle will be equal to this angle. Vertical angles are equal. Vertically opposite angles are equal. This angle will also be equal to this angle. So these two triangles are similar to each other. Ratio of area is 16 into 9. Can we say ratio of side length will be 4:3? So length of AB we can say it's 4x, then length of this we can say will be 3x. Now one more thing, the ratio of height will also be in the ratio of 4:3. है ना? If this is 4x, we need to divide 4x into two parts, which is 4:3. So divide 4x by 7 parts. So it will be 4x by 7. So this length will be 16x upon 7 and this length will be 12x upon 7. 4:3 ratio, right? Now, can we say what do we want is we want 16x square, area of the square, but we know area of triangle AQB. Area of triangle AQB is equal to half of 4x into 16x by 7. This is equal to 16. 16 cancelled out. We can say that x square is equal to, this will be 2 times cancelled out, x square is equal to 7 by 2. What we want? Area of the square ABCD. Area of square ABCD is 4x square, which is equal to 16x square. Now I can put the value of x square, which is 7 by 2. So this is 8 times. What do we get is 56 centimeter square. So an amazing question based on similarity of triangles involving a square, right? I hope you understood this solution and also the rest of them. So thank you.